In this video, we will discuss about piezoelectric transducers. Piezoelectric effect. There are certain materials that generate electric potential or voltage when mechanical strain is applied to them. Or conversely, when voltage is applied, they tend to change the dimensions along a certain plane. This effect is called piezoelectric effect. It was discovered first in 1880 by Pierre and Jacques Curie. Piezoelectric effect are divided mainly into two modes of operation. One is direct effect or piezoelectric effect. When sound vibration occurs on this crystal, electrical signal is produced. That is, when an force or any vibration is applied on one plane of the crystal, electrical energy is applied across the crystal. The inverse piezoelectric effect can be defined as when an electrical signal is applied to a certain plane of the crystal, so sound vibrations can also be produced. So the vibration or sound is converted to electrical signal is called piezoelectric effect. Applying electric signal produces vibration or sound is called inverse piezoelectric effect. Piezoelectric transducers work on this principle. That is, when we apply, for example, this is a disc. When a normal force is applied to this disc, this force or weight, it can be a weighing scale. When the weight falls, it shows a corresponding change in the electric current, electric charge produced across this disc, and it can be measured with a voltmeter. So output of the obtained the output voltage obtained from the material due to piezoelectric effect is very small, and it has high input impedance. To measure the output, some amplification auxiliary circuits are needed. Material used for piezoelectric effect requires certain desired qualities such as stability, output, insensitive to extreme temperature, humidity, the ability to be formed with using any shape. But even though all these are required for transducers, or that has to be made with piezoelectric material, all these properties are mostly not made by piezoelectric crystals. So what are the piezoelectric materials? The crystals are the natural such as quartz. Since they are naturally occurred, they cannot be man-made or cannot be fabricated for required applications. But barium titanate, lead zirconate titanate are not naturally occurring, but they are man-made, so they can be fabricated based on the required applications. The figure shows a conventional piezoelectric transducer. So a pressure port where pressure is applied. So applied pressure is cumulatively summed by the summing member, and it is applied to the crystal on one specific plane of a crystal. This results in the output voltage. Okay, so this output voltage is directly proportional to the pressure applied. So this pressure is can be weight or vibrations, etc. Advantage of piezoelectric transducer: high frequency response and transient response. They offer very high frequency response. That means the parameter changing at very high speed can be easily sensed. High transient response means the piezoelectric transducer can detect events of microseconds, and it gives a linear output. The piezoelectric transducer is small in size and have rugged construction. The limitations being, since it's a low output and high input impedance, it requires sufficient amplification circuit to faithfully reproduce the electric charge from the crystal. Forming into different shape is a problem for naturally occurring crystal, but for man-made substance, they can be fabricated based on required needs. The application of piezoelectric transducer. The applications of piezoelectric transducers ranges widely from vibrational pickup accelerometers to explosion ballast wave applications, automotive companies for detect detonations in engine blocks, to biomedical applications. One of such biomedical applications is used in biomechanics, where measurement of force becomes vital. This force can be force plates used on the legs, or force fingertip or force sensors used on the fingertip force measurements. Okay, thank you.